Example 1, you've got 170 degrees. We want to convert that to radians. So there's a couple of ways that you can go about it. Some of you are going to memorize the formulas for what 1 radian is and what 1 degree is. So if you would remember, or if you had memorized that 1 degree was pi over, and for now I'm going to write radians on the other side. If you knew that 1 degree was pi over 180 radians, well then 170 degrees, how would I get from here to here? I would have to multiply by 170 is going to equal, multiply this side by 170 pi over 180 radians. And you could reduce that if you wanted to 17 pi over 18, but you do not need to reduce things. You could just leave it like that. Now, that would be an exact answer. So it says give the exact measure, but it says also approximate. So we're going to go to our calculator and type this into our calculator as well. 170 pi over 180. And it's approximately say to the nearest hundredth, 2.97. So that's converting from degrees to radians. Now, if you ever forget this formula, you can always create that formula. You can start with, right? You can start with, I know that all the way around the circle, 2 pi radians is 360 degrees. So that means I know that pi radians is 180 degrees. We should never say pi is equal to 180. If we take out the units, it doesn't make sense. Pi radians is equal to 180 degrees, but pi is not equal to 180. Does that make sense? Is 12 equal to 1? Anyone? No? But if I say 12 inches, is it equal to 1 foot? Yes. So if you add the units, it makes sense. But if you take away the units, it doesn't make sense. So we have to say pi radians is equal to 180 degrees. Why do students get mixed up with this? Because there's no symbol for radians. So when you see this, you just go pi equals 180 degrees. And that's a little bit wrong. Okay? Pi is still 3.14. Blah, blah, blah. 1, 5. Blah, blah, blah. And so on and so on. Okay? And then if you can get pi radians is 180 degrees, could you get 1 degree by itself? Yes. You would just need to divide by 180. Pi over 180 radians is equal to 1 degree. Okay, so for part B, we have negative 12 pi over 11 radians. It says sketch the angle in standard position and then determine its measure to the nearest tenth of a degree. So in part B, they got us to do the hard thing first. If we're sketching this, negative 12 pi over 11 in standard position, does it make sense that we're going to be going in the negative direction, so we're going to be going clockwise? Just like we start with 0 degrees here, we would have 0 degrees there. What's halfway around the circle? 180. What would it be in radians? Halfway around would be pi radians. All the way around would be 2 pi radians. how far or in what quadrant would I end if I went negative 12 pi over 11? Okay? Negative, so I'm going to start here. Tell me when to stop when you think I get to negative 12 pi over 11. You are liking math. I should never stop? Just keep going? Am I getting closer? Am I going to have to do this for a couple hours? Did I go too far? Probably. Right? I love asking that question because that means you really don't know the answer. Or even if you kind of know it, your confidence is at that, like, I'm not that confident, so I'm not going to say anything. So nobody says anything, and I just keep spinning forever here. Okay, let's. Okay. Should I do it again? You feeling more confident? If I used a different color, would you purple? Okay. Someone says stop there. Is that too far? Not far enough? Just right. Okay. You are in the right quadrant. Oh, voila, that's a good one. Okay. So let's think about this. Let's think about that's negative pi. Does that make sense? Is negative 12 over 11 bigger or smaller? Should I go more or should I go less than negative 1 pi? More. Why? Because it's more than 1. Negative 12 over 11, I could write that as negative 1 and 1/11 pi. Does that make sense? And so if I took this part and broke it up into 11 little chunks, I don't know if that might even be too big, that would be negative 12 pi over 11. Now maybe we should have converted to degrees first, because then you would have got it right away. But if I wanted to convert negative 12 pi over 11 radians to degrees, I might start with the idea that I know that 1 radian is equal to 180 over pi degrees. So what would I have to multiply by to get 12 pi over, negative 12 pi over 11 radians? I would have to multiply by negative 12 pi over 11. What happens if you take 180 degrees over pi and multiply by negative 12 pi over 11? What do you get? Can you see that your pi's would cancel out? Twelve times 180. $2160. So we could write this as negative 2160 over 11, which, if we rounded this, is 196.4 degrees. Did it say to the nearest degree? I think it did. Yes. Nope, to the nearest tenth. So I should write 196.4. 196.4 degrees. If I did 196.4 degrees, negative 196.4 degrees, can you see how you would have drawn that a little bit easier if you had degrees? Okay? But we have to start getting, and what we're going to be doing is getting more and more used to thinking about things with radians as well. And in this case, changing this to a mixed fraction where we said negative 1 and an 11th, negative 1 and 1/11 of what is left, gives us a picture of the angle as well. And finally, part C says, oh, I want to show you a shortcut for changing from radians to degrees as well. We had negative 12 pi over 11 radians. If you wanted to use the shortcut to change this to degrees, and the shortcut only works when you have a pi with the radians to begin with, since pi radians is 180 degrees, you can replace the pi with 180. You can see why that happened in the work we did above. When we multiplied by negative 12 pi over 11, the pi's canceled out. And all you were left with was the 180. So if you have a pi in your equation to begin with, you could replace it with 180 degrees as a shortcut. All right, part C says you have 7.5 radians. How many degrees is that? Well, we know that 1 radian is equal to 180 over pi. So 7.5 radians would be 7.5 times 180 over pi. You can go to our calculator to type that in. $429.7 degrees. Questions for practice? Numbers 4, 5, and 7.